Welcome physical science students to video number 3, where we're going to look at some speed and velocity word type questions just very quickly, or relatively quickly. Now we should be aware that the difference between speed and velocity is that speed uses distance to be calculated, whereas velocity uses displacement divided by time, and we should be in tune with the difference between distance and displacement. And there's our formula which we use generally speaking. Now, a car is driven 500 kilometers north in 6 hours. Calculate its average speed and its average velocity. Now, to calculate its speed, we first of all identify what we're given. So we're given a distance and a time, and in this case they're using speed equals distance over time. 500 kilometers divided by 6 hours gives us our units, kilometers per hour, and 83.3. We don't have to give our answer in kilometers per hour. We could have been asked to give our answer in meters per second. What would we do in that case? Well, to get kilometers per hour, we use distance in kilometers and time in hours. But to get meters per second, we just need to convert our distance into meters and our time into seconds, and we've done that here. 6 hours is 60, there's 60 minutes in an hour, 60 seconds in a minute, and then there's 1,000 meters in a kilometer, and we get 23 meters per second to the minus 1. Now, working out the velocity looks very similar, uses a different formula and uses S instead of D because this is a displacement. And the main difference is that we've got a direction on our displacement. Happens that the magnitude is the same for both of them, 500 kilometers, and the time is of course the same. However, the calculation is the same and we get 83.3 kilometers per hour, but the big difference is there's a direction. Now, sometimes students get a little bit confused because we often ask questions that ask what is the velocity of this, and there's no direction given. In which case you just work it out with what you've got, or what you have. And you don't have to give a direction if there's not a direction given. And the use of speed and velocity, we rarely get very pedantic about it. In this case, because we're trying to just reinforce the concept or the difference between distance and displacement, we've made a difference here. But generally speaking, in a question, most of the time you're just going to use velocity, and you'll interchange distance and displacement. But, and this is the big but, if you are given a direction, you've got to use it. Or if you can work out a direction, you've got to use it. And that's what we'll be looking for basically in our questions. Let's do another one. Here's a Nissan Pulsar. A long time ago I used to drive one of those, blew it up when it ran out of oil, or oil seal broke. This Nissan Pulsar is travelling 4 kilometers north and then 3 kilometers west in 10 minutes. That seems a bit fast to me. What's its average speed? What's its average velocity? Let's have a look. Now this is a little bit trickier because you would recognise, because it's gone around a corner, this blue lines represent the distance travelled. The red line would represent the displacement from the start to the finish, and therefore this angle here is important because we need to be able to work out that, because that would be the direction of our displacement. And let's work it through. So working out the speed's not too difficult because working out the distance travelled, it's just 4 plus 6, 10 kilometers. Here they've done kilometers divided by 10 minutes. That means that the units that your speed would be in is kilometers per minute. That seems a bit funny. It's not a common unit, but there's a reason behind their madness, and that's because in an hour there's 60 minutes, and so the velocity, if you want it in kilometers per hour, would be 60 times what it travels in a minute, so 60 kilometers an hour. It's not that fast, really. Now, if we wanted, we could have given our answer in kilometers per hour. So we would have just had our 10 let's change the color here. Ooh, let's go this. No, let's go blue. Let's go 10 kilometers. And to get our time into hours, how do we convert 10 minutes into hours? Well, we need to know the fraction, or that 10 minutes represents, of an hour. So how many minutes in an hour? 60. So if we do 10 divided by 60, put that in brackets, and we'd get our answer in, our answer would be in kilometers per hour to the minus 1. Now, if we wanted our answer in meters per second, we just need to convert our kilometers into meters and our 10 minutes into seconds, and we get our answer in meters per second. So sometimes we'll ask you what to give us our answer in certain things. Otherwise, all of these, kilometers per minute and kilometers per hour, meters per second, are all acceptable. Generally speaking though, kilometers per hour and meters per second are the two main ones we'd use. Let's have a look now at working out the average velocity, which is a little bit more complicated. For the average velocity, you're going to have to do three things. What color have I got? Blue? Yeah, let's go green. So we're going to have to work out three things. The first thing that they've worked out is this angle, and they've worked it out using tan opposite over adjacent gives you that ratio, or that number, and then because we want to convert a number to degrees, we use the tan inverse of it, and we get 56.3 degrees, and that's west of north. So north going west. Now another way of stating that bearing is, let's see, north 56.3 degrees west is the more common way of doing it, where the first bearing is either usually north or south, and then you get an angle and it's either west or east depending on which way you want to go. So basically your compass is broken up into north and south, and then you either move west like that, and that's the angle you move, or east, and that's the angle you move. So you can cover all possible angles. The other way of giving a bearing is to have a north there, and let's change colors again. We have 360 degrees moving in a clockwise way, and so east would have a bearing of 180, and it's a 3-digit bearing. So north would be 000, east would be actually 090, south would be 180, and this bearing out here, which we gave over here, would actually have a bearing of 3. Now we don't usually use decimal places, so we'll round it up, which makes it 304. That would be our bearing. But this one is the most common one. This one's not bad because there's no way you can confuse this. Some people can confuse this because they interpret it as you go like that. So you're west, you start off with west and you go 53 degrees north, which is slightly different. So often I encourage students to be very explicit about where they want arrows to point. And another thing to remember is to try and remember to read it as if you don't know what the answer is, because that's what the examiner is going to do. And if you can read it and it points in the right direction, you've stated it clearly enough. Right, now let's move on. So we've done that, and what we've got to do now, let's go back to green, is they've worked out the displacement, and they're using Pythagoras to work out the displacement, which they get to be 7.2 kilometers. Now the displacement is at the same bearing that we've just worked out, and then we work out, so that's the first thing, was to work out the angle. Second thing was to work out the displacement, and the third thing is to work out the velocity. So there's 3 steps to this, so it gets a little bit complicated, and in this case they've worked their answer to be in kilometers per minute, which would have been much better to write it in kilometers per hour or meters per second. Now you could have done step 2 and 3 in either order, so you could have actually worked out the displacement as 7.3 kilometers, and then using any of the angles or any of sine, cos and tan, you could work out your angle. If you don't like tan, some people don't like using tan, some people have their favorite trig ratio, and so you just use your favorite one. So you could have done that first once you know the hypotenuse, which is 7.2. Hope you get that. Alright, and so let's get rid of all that writing. In the next video we'll be looking at acceleration. See ya.